Hi everyone, my name is Geert-Jan Geertsma and I'm working for the Electrical Engineering Department of Hanze University in Groningen for the studies Sensors and Smart Systems. Well, for this taster course I will tell you a bit about sensors and about a so-called serial data bus. Yes! Well, what we're going to talk about has a real-life application. Imagine yourself having a plant at home. The plant needs to be taken care of, it needs watering, it needs light. And maybe you want to automate this process by applying a plant monitoring system. So what do you need to control when you want to monitor a plant, and what do you want to do when you want to take care of the plant? Well, take a look. Light exposure is an important factor, air temperature, soil moisture, humidity and air quality would be measurable parameters. But to control and take care of the plant, you would maybe water the plant automatically and nutrients delivered automatically. Okay, for this purpose we have a number of sensors in place. You can find a humidity and temperature sensor over here, air quality monitor sensor, a soil moisture sensor and a light exposure sensor. And these sensors, they gather data which needs to be sent to a computer system. And to make an analogy about sending of this data, we will talk about, you can imagine yourself to be at an airport, you're waiting for the airport to be boarding. You're with a huge crowd, 200-300 people waiting to board the airplane. Boarding the airplane is done one by one. So every passenger gets on the airplane one by one. And at arrival, you also leave the airplane again one by one. And we're going to talk about communication of data from these sensors, where we actually are using bits. And these bits are also sent one by one from a source to a destination. Just about a sensor, what it's actually doing? Well, the name already indicates it's sensing something. And in this case, it's sensing something like a room where it's completely dark. And to translate this into something electrical, you can create an electrical signal, let's say 0 volts. So a dark room equals to 0 volts. And once the light turns on in that room, the sensor detects this light and the output of the sensor will be 5 volts. So you can detect for light and for dark. This voltage, the 0 volts or the 5 volts, is for computer processing, is translated into a binary value. The binary value could be 0, in our case 0 means 0 volts, there's no light, or it's 1, that means actually there's light present inside that room. So actually this is what we call a 1-bit value, which can be either 0 or can be 1. Well, you can extend this, of course. You could also say the room is not completely dark or it's completely light. It's something in between. Let's say at a certain level there is an output voltage of the sensor to be 2.5 volts. And you can codify for the 2.5 volts by including more of these binary values. And in this case you can see there's 8 bits established over here. 8 bits together are called a data byte. And again, 0 volts is meaning a decimal number. 0 means a binary number, which includes all zeros. And completely light, 5 volts, means all ones. And something in between, as you can see over here, is expressed in this binary number. This was about the light sensor, but we got a number of other sensors also. We got the humidity sensor, the soil moisture sensor, and we got the air quality monitor sensor. All these sensors, they actually produce a voltage which is in the range of 0 to 5 volts. So they can all be codified into this binary 8-bit scheme. Yes! Okay, once we got these sensors all selected, we're going to hook them up using a number of wires, and there's a computer included. In this case it's an Arduino Uno, and you can see there's a bunch of wires in between the sensors and the computer. And there's a display for you to be able to read off the values of the current temperature and humidity of this particular plant monitoring system. What we need to talk about is something about communication between two computers. As we already know, computers, they are using 8 bits or bytes internally to store data about humidity and light. And if you want to send a byte from one computer to the other computer, we can do this in many ways, but in the way we are going to discuss right now is we call the serial way. That means you only have one single wire, and through this wire you're going to, using voltage manipulation again, you're going to transmit the zeros and ones. And you can clearly see over here, a 0 means 0 volts and a 1 means actually 5 volts. So if you take this sequence of zeros and ones from one computer, computer A to computer B, the second computer has received, after it received the individual bits, the entire byte at the other side.
Yes!
Okay, we can extend on this. We can build what we call a data bus. And this data bus consists of a small number of wires. In here, actually, there's only two important wires. There's the data wire and there's a so-called clock wire. We won't go into the detail of the clock wire. It's essential for the operating of the data bus, but we're going to focus on the data wire. And you can see that the data wire, but also the clock wire, is connected to all those boxes you can see over here. The blue one, and there's three orange ones. The blue one is basically the master controller of this so-called data bus, which is in this case again the computer, which is the Arduino we have been using. And the orange boxes, they actually individually are hooking up as the sensors for light, for humidity, and even the display is connected. Well, the controller can communicate to every single device using that data bus. But to be able to discriminate between these devices, every device on this bus has its own unique address. So for instance, when the controller wants to talk to the light sensor, it will use the first address, address 1. It exchanges the data, and then maybe it wants to display this data on the display, and it will address then the LCD display in this case. Okay, looking at the data bus again. Here you can see that the data bus consists of a serial set of bits being transferred over the data bus in the green area, and the yellow area shows you the clock signal, which is required to basically synchronize the data being transmitted between those two computers. This is just an example of a serial data bus. There are many other serial data buses in use. For instance, commonly used one is the USB. You use for your computer devices, but also a CAN bus is available, which is running through your modern cars. And I2C actually is the example we have been looking at during this presentation, during this course.
Yes!
Well, I hope you learned something of this taster course of today, and it will help you to decide on which studies you want to proceed with. Maybe you'll want to take some extra information which is present after this course, and there's also a short question and answer test you can take. So I wish you good luck with your choice, and maybe I see you next year.